prior to this module, we were looking to the behavior of change, and in this module, we are going to look to the rate of change. We talked about that how the steepness of line joining two points is related or is equated to the rate of change. Welcome to the lecture 3.1, Mathemagic 2.0. We by now know that what exactly is meant by the rate of change. In the previous modules, we know the behavior of change. In the last lecture, we talked about the rate of change. Today, we'll associate that how the steepness, how the behavior of change reveals the rate of change as well. So we have seen that for any given instance, say for example, if this is the time being elapsed and this is the distance travelled. Now, if I look to point OA and point OB and point OC, look to this, that this becomes the time to reach from point O to A. This becomes the time to reach from point O to point B. And this becomes the time to reach from point A to C. What basically is differing in these three things is the angle. If I can say that this is alpha A, this angle is alpha B, and this angle is alpha C. Look to this. If I divide, say for example, if I divide the distances travelled, TA, or this becomes the DA, distance travelled by OA. This becomes the distance B, and this becomes the distance C. We know that TA, the time taken from O to A, would be greater than that of time taken from O to B, is greater than the time taken from reaching from O to C, whereas the distance travelled by A is less than the distance travelled in OB, and the distance travelled in OC is less. So, for greater amount of time, the distance travelled, lesser the time and more the distance, means if you take distance by time, so the highest rate of change comes out to be from O to C, and this is nothing because the angle or the steepness of O to C is greater than that of the steepness between O to B is greater than that of steepness of point O to A. Now this steepness is nothing but depicting, as I said earlier, that steepness would equate or be equivalent to the rate of change. Now, another good example out here, if I can cite, look to a scenario that there is a time and there is a distance. Say for example, one moves into this scenario. He starts from the origin, or the time is 0 and the distance is also 0. If the rate of change is slower, means for this duration of time, if I again consider this to be point A and this is point O, the time taken for this particular thing be TA, and the distance travelled, you look to the output over here, the distance travelled from O to A be dA. So the steepness is less, thus the time taken to travel such a short distance, this is a short distance, the time taken is longer. Now if this can be treated as what? A person walking. Now if the same person starts jogging in the scenario, what is going to happen is that in a shorter duration of time he will be able to travel the distance more. Now this is point B and this becomes the time TB, because we have the focus is between O and B and the person is doing what? Jog. Look to this scenario, that because of this steepness is more, for the less time consumed, he can move a larger distance. Another, if I look to it with running, the same scenario, see the steepness is greater again and he has reached to point C. In the shortest, or out of these three, shortest possible time, that is time taken between O and C, is the least and the distance travelled for this particular thing is the greatest. I'll give you one more example. That say for example you need to travel to a particular distance, be it X or maybe be it Y kilometers from the start point. This becomes the start point and this becomes the end point. This becomes the end point. Now this is the line depicting the end, because this side or the vertical line is depicting the distance travelled. Now this is depicting the time of travel. If somebody is slower the approach for the given time, the time taken would be longer. This is the time when the mode of commuting or the steepness is slower. The steepness is this. The time to reach to this point, maybe Q, that is the end point, finish line, is the time taken Q, which is this. If the person is taking maybe a motorbike to travel or to ride, then the faster the rate and the time to reach the same end point, that is Q or Q prime, would be less, because this will be the time taken is as TQ prime. But if the person is driving a car which is faster, possibly faster than the motorbike, then it will be something like this, and to reach to Q double prime, because they belong to the same distance from the start point as this is the end point, the steepness is highest and the time taken over here would be the smallest. So TQ double prime would be smallest. Lesser time because this is the fastest, this is the faster, and this maybe you can say that you were doing a cycling kind of thing, you were doing a bicycle kind of thing. This is the scooter or the motorbike kind of thing, and this is the car. So this entire scenario depicts the rate of change and correlates it with the steepness of the graph or the steepness of the line joining between the starting point and the end point. So we can very well conclude once again that the steepness equates to the rate of change. So let us look to a scenario, let us look to a situation. This is a curvilinear surface, we all know. Now the behavior of the function can be curvilinear like this. If I take a cut section and create a plane, there is a curvilinear shape, and in order to assess the curve, I put a straight line out here. I put a straight object. Now this is where this particular straight line is touching this curvature. At this point, this is the tangent. Now if I roll it over and come to this particular scenario, at this point this tangent is now for this point of the curvature. Now at this point the tangent is now for this particular curvature. So this straight line is touching this curvature at a given point of time and touching once. This becomes the tangent. We are going to look to that how this tangent at a given point is going to reveal, is going to tell us the instantaneous rate of change. The slope of this tangent is going to tell us that what is the instantaneous rate of change at that point of time. I'll see you in the next lecture. Thank you.